Hi, everyone. Thanks for being here. This is the before last session. So we have Nikhil. He's the project lead for Eclipse Collections, and he's going to talk us about do-it-yourself collections. So, Nikhil, thanks for coming here to Genation. You are based on Houston, Texas. So, how's things around there?
They're pretty good. Things are warming up now, so it's the start of the summer and the hurricane season. So yeah.
Well, let's hope that you don't have much trouble with that. So let's go to the presentation and good luck.
Thanks, Bruno. So thanks a lot, everybody, for watching the live stream. As I was telling Bruno before, if I would have traveled to Portugal for J Nation, which I was really looking forward to, it would have been my first visit to Portugal. So, but at least I get to give the same session online, and then we have it on YouTube pretty much forever. So again, thanks a lot for giving this opportunity to me. My name is Nikhil Nanivadekar. My Twitter handle is Nikhil Nanivade. I'm pretty active on Twitter. Most of the time, I tweet about collections or food or my hiking trips whenever I get to travel. Like Bruno mentioned, I'm the project lead of Eclipse Collections, and this is our website, eclipse.org/collections. And for those who are interested, like we have the website in multiple languages, and one of the languages is actually Portuguese as well. So take a look, give it a go, and let us know your feedback about the project itself. If you like it, you can put a star on the repo of Eclipse Collections as well. Today's talk is going to be do-it-yourself collections. In this, I do not use any Eclipse Collections code. It's all based on the JDK code. The way the session is designed to flow is, first we'll take a look at a bit of basics of collections. Then we are going to implement in the next about half an hour two new collection types. One is bag or multi-set, and the other one is multi-map or multi-valued map. The code for the entire talk is available on GitHub as well. That's the repo which I've highlighted. So with that, let's get started. So as I mentioned, the very first point is, what are collections, right? Essentially, collections can be considered as one of the basic building blocks of any code. And the reason why I say one of the basic building blocks is, generally you can operate on things which are, just one thing. But most of the times we get a collection of objects on which we are trying to perform an operation. So currently in the Java ecosystem, we have three main types of collection. The first one is list. In order to define list in an abridged way, a list is an ordered collection uh, where uh, where the insertion order is retained and duplicates are allowed. So duplicates are allowed. So essentially, anytime you're adding elements to a list, you can add duplicates to it, and it's pretty much, once you add an element, that location of the element is guaranteed, and it's guaranteed during iteration order. So that's the definition of a list. The next one is set. So set is generally a hashed data structure, and there are, again, the reason why I say generally is because there are some exceptions as well. For example, a linked hash set, where it's pretty much the linked list implementation of a set, but we for most of our purposes we end up using a hash set, which is a hashed data structure, where only unique elements are retained. Okay, are retained. And because sets are unordered, or rather sets are hashed, the ordering is not guaranteed. But again, if you're using an ordered set or a sorted set, then the ordering is definitely guaranteed. The last but not the least of the data structures is a map, where essentially you a map is a data structure which has a key to value relationship slash pairing. So essentially, for every key you have a value, and a map only retains unique keys. Okay, so just by the virtue of you having one key, you know that you have a single value. All right, so we just looked at the three basic types of collections. Now, as and how we are developing code in Java, we realize that like we have these three basic building blocks of collections, but sometimes they're just not enough. You end up extending these collections, and once you end up extending these collections, you open a whole lot of possibilities for you to actually do different kind of operations. Okay, and with that, like there comes a necessity for two different data structures or two new data structures. The very first one, we can call it a bag, or it's also called as a multi-set. Now, the reason why it's called as a multi-set or a bag is because essentially this data structure pretty much mimics how your shopping bag or your shopping cart example can be, where you have an element and you have the number of times that element is there. So for example, 5 apples, 4 bananas, 6 oranges, just an example. So you have essentially an element and the count. So now, in order to make it more understandable, let me actually write it the way we would like to store it. So apples 5, bananas 4, and oranges equal to 6. So this is pretty much what we are saying. So if you take a look at it, just by looking at this definition, bag seems to be nothing but an extension of a map. So the way we want bag to behave is similar to a list. Okay, similar to a list where duplicates are allowed. Okay, duplicates are allowed. It is similar to a set where said where the elements that are retained are unique, as well as the data structure is hashed. Okay, structure is hashed, and at the end of the day, it is similar to a map where the element to the count is denoted or is available rather. Okay, so that was the first data structure that we are going to build. So enough of me talking, let's get into code. And the way I've set up this repo is all test driven development, where I have some tests which I have written, and they're easy to understand. Create, add, remove for each. Just simple basic patterns which are there. And right now, all of these tests are essentially failing, as you can see. And now, in the next about 15-20 minutes, we'll end up implementing all of these failing methods, and take a look at how we are implementing the bag. And as I'm implementing, I'm going to try and explain to you why I'm implementing something in a particular way. And now imagine this, right? Like currently in the JDK, we do not have this multi-set or a bag data structure. So whoever is, has a need for a similar use case, they are essentially implementing pretty much this exact same data structure with these exact same control points that we are going to discuss later on in their own repo, and they're maintaining it. So I mean, JDK is powerful. We can do a lot by extending JDK data structures, but these are the nice to have data structures which actually help us enhance our development uh, development with collections in Java. So let's look at constructing a bag. And as I mentioned before, our bag is essentially backed up by a backing map. And the backing map is of type T, which is generic object, and integer, which is for count. For convenience, we also have a size which we are caching out there, so that we can return the size fairly easily. So in this constructor, we are basically getting an array of elements or a vararg of elements, and then essentially we have to go over each of these elements, and we have to do stuff with these elements. And I'm a massive fan of IntelliJ, and I use IntelliJ in my entire development. So that's why you'll see some of the live templates that I end up using. So the very first one is we are creating this bag. We got an array of elements, and we are going over one element at a time. What we are trying to do is we are first trying to get the backing map and see if a particular element exists or not. So let's say, element and existing. Now, if the element is existing, then what do we want to do, right? If existing not equal to null, then we're trying to do existing equal to existing plus one, correct? And we can, of course, refactor this to just do plus plus and get done with it. And if it is else, we are going to say existing equal to one, and then we're going to say this dot backing map dot put element comma existing. All right. So essentially, we are adding a null check there. We are incrementing the counter, and at the end of the day, once we put it, we also need to increment the size. So this dot size is equal to this dot size uh, plus one. And again, you will see most of the times I'm not doing the plus plus or doing the plus equals. But I mean, again, at the end of the day, we can definitely uh, use IntelliJ and all the other power tools which are there to do that refactoring. But the first thing that I want to show is this code. Looking at it, it's fairly straightforward, right? But still my tests are failing, and my tests are failing because I expected 2, but right now it's only 0, right, for Apple. Now why would that be? And the reason for that is out here, while I was doing this refactoring, I made a mistake, right? Because it's existing plus plus, but existing was you know it, it became 1, and then after that, like plus plus, I have never retained that. So it should be either plus equals, or what, we'll just go back to existing equal to existing plus 1 for now, because we are going to once this test passes, we are going to refactor this whole thing to use the JDK method. So let's see why it is still failing. Oh, it's failing because get occurrences, I've never implemented it. So let's go ahead and implement that. So return this dot backing map dot get, and the JDK has defaults as well. So we are just going to do get or default, and the default value is 0 because we don't want to return a null, right? So that is it. And while I'm at it, I'm just going to implement these other helper methods where I want to return the size as this dot size, and I want the size distinct is essentially going to be the backing map and the size of the key set, because again, the keys are guaranteed to be unique in the map. So that shows us the distinct size. All right. So now we got the create test to pass. Okay, but this is a lot of code, right? And this code is very easy to refactor with the existing API that we have with the JDK map. And the reason why I wrote it in a very long-winded, verbose way is first things first is I needed the test to pass to understand that I have a working implementation. Now, the JDK hash map actually exposes an API which is called as merge. Because if you see here, that's exactly what we are trying to do. We are trying to merge two values. Okay, if something was already present, then we are trying to add one. If something was not present, we are trying to set it to 1, and then we are putting it back in. So the merge API in the JDK map does exactly that, where it takes in an element, it takes in an integer value, which is to initialize something, and this is going to be 1 to initialize it, and then uh, it takes in existing comma we don't really care about this next value which is there. It's for concatenation, but we want to do just existing plus 1, and that's it. That's pretty much the code that gets replaced out of this, where your null checks and everything are hidden. So this is an additional level of abstraction that you can give to the user. So let's run the test. So create has passed. Okay. Now, if you see, I've got two of these like, little methods for each and for each with occurrences. These are nothing but, iteration helping methods. And I'm going to quickly go fix them because they're super straightforward. For each with occurrences says that like, hey, I have an element and I have a count. I want to iterate over that element and the count. And just because we have implemented the backing map in that way, we can just simply delegate it to the for each of the backing map and pass in the by consumer. The for each part becomes a little bit interesting, where essentially we have to apply the consumer for every single element. Now, the way we have implemented this is it's essentially an element and a count, right? Or the occurrences, as we want to call them. Now, it's a non-zero count, so essentially we have to loop over and apply the consumer as many times as there is the count object. So sorry, as the number of count. So let's do a quick for loop, and for I less than count and I plus plus, and then we're just going to say consumer, not continue, consumer dot accept element. All right, so with that, I think we implemented two more methods. Now, the thing that I wanted to show is out here, it's very simple to make mistakes. Like someone might start at 1, it's less than or equal to. Again, we're trying to abstract these methods out, and we're trying to give these helper methods to our users who will use our data structure. Again, these are fairly straightforward. We can implement it over and over again, which we want. But again, at the end of the day, we sort of want to generalize this, and just having this sort of data structure available in the JDK itself will make it a bit more convenient. So going on to the next implementation is add and remove. Now, add and remove, as we saw here, when we were creating a new bag, we were essentially merging the elements. So add ends up doing the exact same thing. Um, and if I like to give, like, these lazy, no, I wouldn't call it lazy, I like to give these helper methods for programmers, because if you just want to add an occurrence, you don't want to, like, call this method, versus you can just call like this add occurrence method and just apply one, and internally we can just delegate it to add occurrences an element comma 1, and I'll do the exact same thing for remove occurrences by delegating it with comma 1. Okay, all right. Now we are back to add occurrences. Here, essentially what we are trying to do is similar. It's pretty much similar to what we did in the constructor. However, the difference over here is in the constructor, we are going one element at a time. Over here, we get a count that we want to increment that particular element with. So let's take a look of what the API would be. And this time I'm going to directly go to my merge, because we have already seen that API and what needs to happen. So now we are trying to merge the element. If the element doesn't exist, then yeah, replace it with the occurrences. Now, if the element exists, um, existing comma e, which we don't care about the e. If the element exists already, then I want you to do existing plus occurrences. Okay, and once that happens, as you know, we always have to increment our size as well. So size is equal to this dot size plus occurrences, and I'm just going to do, this time I'm going to do plus equals. So because it's fairly straightforward, and then I want to return the output of, so we have a couple of options. We can, and as API providers, it's up to us to decide. We can either return the new occurrences, or we can return the old occurrences. Now, in case of a bag, it makes more sense to return the new occurrences. So I'm just going to do a little bit of shuffling over here, because in order to make it a bit more optimized, as merge will return exactly what I want to return out of this method. So let's go run this add occurrences method and see if the test pass. All right, so the test pass. So it's a fairly straightforward, again, one line, pretty much one line implementation. So the next one is remove occurrences. So essentially, if you can add, you should also be able to remove. So, but removal always creates an interesting problem. Adding is fairly straightforward, right? If something is not there, you create a new you create a new entry and you put it with that particular element and the occurrences. But when it is removing, we have a big decision to make out here, because let's say the number of occurrences that the user is asking to remove is more than the occurrences that are there in the map. What if it does not exist at all? What if it is the number of occurrences the user is asking to remove is less than what we have in the map? So we have pretty much these three conditions. Okay, so let's solve them one at a time. So this dot backing map dot let's get element. Okay, and let's do existing. Now the most the most straightforward of all of this is when existing is null, right? So we'll return false because we didn't remove anything. But if existing is not null is when all the fun fun begins, right? Now, if existing is not null, we have two options. The first option is if existing is less than or equal to the occurrences, okay, or else existing is essentially greater than the occurrences. So let's see, if existing is less than or equal to the occurrences, then in this case, again, as an API provider, I would want to basically evict the element, because in terms of occurrences, you don't want to go negative. It will be a fairly straightforward implementation to do, to just go on reducing the count, but the number of occurrences. But it does not make sense when we are dealing with real world issues. Like, for example, when you're dealing with like a problem statement like a shopping cart, if a user wants to remove 4 apples, but they have only 3 apples in their basket, right? You can't go remove a -1 apple. So that's the reason why we pretty much floor it to 0. So if existing is less than or equal to the occurrences, then we essentially want to do this dot backing map dot remove the element. And as always, we have to adjust the size as well. So we want to do this dot size is equal to this dot size minus existing. All right, and let's fix that for brevity, minus equals. And in case the existing is actually greater than the number of occurrences, then we want to do an in place replace pretty much. So we want to put the element comma, we want to do existing minus occurrences. Okay, that's exactly what we want to put. And then we want to do this dot size, because we always have to adjust the size, minus equals occurrences. So that's pretty much the implementation of remove. Now again, the whole idea of this talk is, yeah, you can definitely extend the map data structure, because this is nothing but simple operations on the map object, on a map data structure, exposing helper methods. While I'm talking, let me just run the test to see my implementation is right. And okay, all right, all tests pass. So my work is done in implementing the bag. So just giving a recap, as I was giving before, the entire implementation of bag that we did right now, it's essentially just based on the JDK map. I did not use anything special. You can see in my imports, it's nothing but JDK imports, and it's a hash map that this backing map is using, and all this API is available. But the API is available in the sense where uh, it can expose the users to a lot of issues, especially around null checks, around the loops, around like all the border and the edge conditions, especially around the removes and the adds. Now, by creating a data structure like this, we are solving a business problem of having a shopping cart, or like having a counting data structure, so to say. And we are adding the additional safety around what makes sense, and we are exposing bag specific API as well. And the bag specific API that we saw was, instead of a get, we are essentially exposing a get occurrences, which is again guarded to return a 0, right? The bag specific API is around add occurrence. We are not just saying add, we are making it much more verbose, and we are trying to explain what exactly we are trying to do in that. So that was pretty much the basis of bag. Now, the next one that we're going to look at is a multi-map. Okay, a multi-map or a multi-valued map. Okay, multi-valued map. So essentially, this is where a traditional map just has one. So let's start typing. A traditional hash map has, or I would even say a traditional map has a key to value relationship, right? But it is essentially a single key to single value. All right. Now, in a multi-valued map, we want to have a relationship of single key and multiple values. Okay. Now, the multiple values aspect of it is what makes a multi-map interesting, because a multiple values is essentially another collection that we are talking about. So multiple values is nothing but another collection, and the another collection can be a list, a set, or what we just implemented right now, a bag. Okay, and that way we basically have a map which has a key and a list as a value, which has a key, and a set as a value, or which has a key and bag as a value. Okay, in the next about 15 minutes or something, we are going to end up implementing list multimap and set multimap both. Again, similar to the bag implementation, I also have failing test cases created, where I create set and list. My very first naive test is just doing null checks to make sure that these objects are getting constructed or not. But as we keep on going ahead, we see like the test becomes more interesting. So the very first one is put on a set multimap. So if I dive down a little bit and show the hierarchy, I have an abstract class called as a multimap, which is extended by a list multimap and a set multimap. And the reason why this is called as a list multimap and sorry, this is called as a set multimap, and uh, the other one is called as a list multimap is because of the collection that backs the map. So that backs the values. So essentially, a list multimap has the value collection to be a list, and a set multimap has the value collection to be a set. Okay, and we initialize them as a new hash set, and this guy as a new array set. So let's start implementing one method at a time. The first two that we see is get and put. Let me first implement get, because I do want to show something to folks. And again, similar to a bag, this is backed up by another hash map itself, but this is a map of type K, and the value is a collection of values, not just one V. So the traditional value has become a collection of values, and the collection is a list or a set depending on the multimap. So now if you see the get which is there, we are essentially going to do a get. And in this case, again, we are trying to make sure that things are pretty much null safe from a final user perspective. So instead of just returning a null, what we'll do is if something doesn't exist, we will return the empty backing collection. Okay. Now put is where things become interesting, because now there are a few options, right? Like if if a particular key value pair does not exist, then you need to create the empty backing collection and then put the key and the value. If it already exists, however, uh, you have to consider what is the backing collection to decide whether to put that value or not. Because as I had mentioned before at the start of the talk, if it is a list, it allows duplicates, so you can go on adding the values. If it is a set, it only allows unique elements to be retained. So in that case, it does not make sense to add the value. However, for the sake of this talk, we are just going to be a little bit lazy and delegate it to those collections itself, to see what essentially happens. So now, similar to the get, we are going to go with this dot backing map dot get or default. Okay, and then we'll get the key, and if it is empty, then we want the empty backing collection. Okay, and we can call this as existing. All right, and then we just want to do existing dot add value. Okay, now the interesting thing is, once you add value here, let's see what happens, whether the that just satisfies our use case, or that does not satisfy our use case. Well, that does not satisfy our use case, because if you see here, I've only updated the existing, but I have never put it back, right? So we have to go back and we have to essentially put the existing um, the existing collection. So let's run this, and hopefully, yeah, hopefully the test for put did pass. So again, put and get was fairly straightforward. Put all, I'm not going to implement. It's like, homework if folks want to take it, take a look at it. It's fairly straightforward as well, similar to put. But in this case, you get an iterable of values instead of just one value. The next one on the list is if we did the put, which is equivalent to add, we should be able to do the remove as well. Now, amongst remove, the removal is fairly straightforward, because you get a key and you just say this dot backing map, and you remove the key. So you basically remove the key as well as the value collection from it. Now, the interesting implementation comes when you have a key and you have one value, and then you have to again, you get three different possibilities, right? The first possibility is if a particular key and a value does not exist. The second possibility is if the key exists but the corresponding value does not exist. And the third possibility is the key and value, both of them exist. Now, the third possibility makes it even more interesting, and let us start typing the code a little bit, and then I'll explain why. So let's first deal with the get part, which is the key, and then let's do existing. All right. Now, if existing is null, then we are going to return false. So that's why I added an if loop, an if statement to check whether it is not null. All right, so existing is not null. That means the key at least exists, right? Now we have two options from a performance perspective. The first one is we can say if existing dot contains value, then do existing dot remove of value, right? That is one option. And then we can adjust the size and everything. By the way, I did not adjust the size over here, so this is something that I should do. So this dot size. Oh, that's because I don't expose the size API directly over here. The size API essentially ends up coming from the backing map itself. So that's good. All right. So let's move on. Let's move back to remove. So we have one option, which is to do existing dot remove only if it contains, or the other option is just try to do existing dot remove. Okay. So if existing dot remove, that means we have been able to remove something. Okay, then there are two possibilities, right? The first possibility is that if existing dot is empty, and the other possibility is existing is not empty. So now, if existing is not empty, then we just want to do this dot backing map dot put it back to how it was. But if it is empty, we get two options. One option is we keep the empty collection as is, and then basically block out that key and that collection. Or the other option that we have is we simply remove the moment existing becomes empty. Okay, so let's go ahead and remove this, because again, what we are trying to do is we are trying to make this API with enough controls around it, so that it's null safe. Two, it is also a bit performant as well. So the moment you remove the key, you're essentially removing that backing collection as well. So with that, we have essentially removed remove the key as well. And if since we are out here, we can just say return true, because we ended up removing it. And that's it. Let's run the test and see whether remove worked or not. All right, so the remove part also worked. Now, because the way MultiMap was implemented, essentially this was an abstract class, and it is extended by list and set, where all these two classes are doing are essentially returning the empty backing collection. One is a list and one is a set. And the entire API on the multi-map itself is implemented by taking this backing map, and our entry point to this entire value collections is always this get empty backing collection. So essentially we have delegated it to every single of these multi-maps, like a list multi-map or set multi-map, how exactly the backing collections should behave. So thereby what's happening is, whenever you call a put, essentially if the existing dot add is on a list, it is end up delegating to the add of the list, and you are essentially appending the value to the list. If it is on the set, then it is following the semantics of a set. So just to do a quick recap, in the last recap, so in or summary, let's call it summary because that sounds better. So in summary, we looked at the basic types of collections, namely list, list, set, map. We added basic implementations of bag, which is multi-set, and multi-map, multi-valued map. Uh, we we looked at some of the controls around null checks, then size optimizations, etc. In order to make the new data structures uh, well suited for a broad use case. And that's pretty much what we did. I mean, in the last 35 minutes, we ended up implementing 3 new data structures: bag, list multimap, and set multimap. With this, I'll pause for any questions. Again, thanks a lot for giving the opportunity for for me to present JNation.
Hi, Nikhil. Thanks very much for your presentation.
Yep.
We have no questions at the moment.
That's great. Okay.
But I can ask you a few questions. So, Eclipse collections, do you have other types of collections like concurrent, dealing with
Yes.
concurrency and things more complex?
Yes. So again, the only reason why I'm mentioning Eclipse collections right now is because you asked that question. I had kept this talk to be completely JDK, but thanks a lot for asking that question. It gives me an opportunity to.
I'm very curious.
Okay, so Eclipse collections essentially comes. So first of all, it's eclipse.org/collections. Okay, if you take a look there, and the GitHub repo for that is github.com/eclipse/eclipse-collections. So we have our own implementations of list, set, map, bag, multi-map, as well as primitive collections. So for all the primitives that we have, we also have um, primitive list, primitive set, primitive maps, primitive bags. Okay, then in addition to that, we also have our own implementation of, let's say, some of the concurrent utilities like concurrent map. In addition to that, we also have additional data structures which support where it is multi-readers and a single writer. So we call them multi-reader maps. We also have synchronized version of all the data structures as well. We have our own implementations of stack as well, because the stack in the JDK, it's essentially first in first out instead of first in last out. So or last in first out, however you want to look at it. But the Eclipse collection stack is actually last in first out, like a proper stack. So we have all of these data structures. So to elaborate, we have list, set, map, bag, multi-map, multi multi-reader collections, synchronized collections, then primitive collections. And if you go on the repo, I think I can do that. We also have our complete hierarchy. Okay, let me know when you can see. And yeah,
Yes, we
we
can
have.
see it.
Okay, perfect. So we also have our reference guide, and in the reference guide, like we have this entire hierarchy, the way it works. I'm trying to find out one of the mind maps that we have, and the additional aspect of Eclipse collections is where we have a rich API where all of these helper methods which are there, they are essentially given to you on the collection itself. You don't have to call dot stream or anything like that. So there you go. These are our basic collection types, primitive types. We also have immutable collections. I forgot to mention that, so I should put that here.
Yeah, I was about to question you about that, because
Yeah,
immutable collections are very useful in some cases.
yeah. We also have unmodifiable collections. So yep. Let me search for the mind map real quick, because yeah, there you go. So this is our entire hierarchy. I mean, it's sort of difficult to read it out here, but it's available for you to go you know take a look. But yeah, these are all our data structures. Convert the way it is sort of arranged is according to the protocol, according to the functional interfaces, according to data structures. So if you see, we have list, set, bag, and then within the list also we have different types sets. We have different types, then stack, then something which is map like. Then we also have different protocols like as lazy, we have eager, so we have also as parallel. So a lot of features. So give it a go.
Can you
Yeah,
send me that link through the chat, so I can post it later on Slack, because I think
sure.
I find it super useful. Or even if you want to tweet it, uh,
Yeah, I will.
it would be great.
I will definitely tweet it. I'll send all of these links. Here you go.
Okay.
Yeah.
Thanks very much.
Okay.
So let me double check if there's some last minute question. No, I think we are done.
Okay,
So
that's
Nikhil,
perfect. Yep.
thanks
So
very much for being
either I
here.
did a very good job or a very bad job, and I'm an optimistic person, so I think I did a good job.
Oh, don't worry, because right here it's almost 11 in
Oh
the
wow.
evening.
Good.
Okay, thanks very much for being here, and looking forward to see you next year in person, if everything gets a bit saner than this year.
Okay, that sounds like a plan. Thanks a lot, Bruno, uh, and everybody for actually putting this together, Roberto, and giving the opportunity for me to present here. And thanks a lot for staying so late and coordinating everything. You all have done a stellar job. So again, kudos. Thanks a lot. And I'll look forward to meeting all of you in person again. Yep. Bye
Thanks
bye.
very much. Bye
Thanks.
bye.
Take care. Stay safe and healthy. Bye bye.
Bye.